Hi, I am Curious Vedant, and welcome to season 3 of my podcast. Today, my guests are Dr. Aswathy Menon and Dr. Ananth Vikas. Dr. Vikas, my uncle, is a return guest on my podcast. You can find the link to his earlier interview in the show notes. Dr. Aswathy is my aunt, and both of them are pathologists and work at Newburgh Anand Reference Laboratory, Bangalore, India. Hi, both of you. Welcome to my show.
Hi, Vedant. Thank you for having us on your show.
It's wonderful to be back.
We're very excited to be here.
Yeah, when I interviewed Dr. Vikas, I learned a lot about pathology. I'm excited to learn more here.
Yes,
Us
I
too.
hope. Yeah.
Us too.
In the past 18 months, coronavirus has changed life as we knew it. I'm curious to know, what is a virus?
Okay, so Vedant, virus is a type of microorganism. It's a microorganism because you cannot see it with your naked eye. You need a microscope to see it. It's one of the smallest organisms that's there in the planet. And it's actually one of the simplest organisms as well. But what's amazing about the virus is that despite its very simple structure, it can cause such a wide variety of disease. So what is a virus? If you look at the structure of a virus, it's basically just a little bit of genetic material, which can be either DNA or RNA, and it is covered with a protein coat. That's all that it is. It's basically just a bit of protein that's found in nature. And the other thing which is interesting about a virus is that by itself, it cannot multiply. It really cannot live by itself. It's pretty much a non-living thing when it's not inside an organism. So for a virus to multiply, it has to enter a host cell, which can be anything. A virus can infect a bacteria, a virus can infect a plant, it can infect an animal, and as you know, it can infect us human beings also. So once a virus enters a host cell, what it can do is it kind of injects its genetic material into the host cell. So when a virus infects a host cell, what happens is that it injects its genetic material into the host cell and it forces the host cell to make copies of the virus. And that is how a virus multiplies.
And that's how the COVID-19 has multiplied across the world, right?
Exactly. That's exactly how it has happened.
What are the most common kinds of virus?
I think Vikas can take that question.
So viruses are more or less all around us in the world that we live in. There are viruses that infect plants, there are viruses that infect animals, and there are viruses that infect humans. And among these, there are fewer viruses that actually cause diseases in humans. If you ask me, I think the commonest virus that is around us would be the virus that causes the common cold, which is called a rhinovirus. And I think you can hear from my voice that I've just recovered from a common cold. So it's pretty much all around us. And probably the rhinovirus is something that is the commonest. It causes the sniffles and the common cold.
How is virus created?
Viruses, that's what Vedant. Viruses are there all around us. It's kind of, there are a lot of theories as to how the virus originated, and people are not really sure about how that happened. But many people think that it could be a part of bacterial DNA, which kind of separated from the bacteria and learned how to exist by itself, because it's basically just genetic material with a protein coat. So that is probably how viruses were formed in nature. It's been there for millions of years.
And then they're naturally occurring microorganisms, Vedant.
Yeah.
And are new viruses created all the time, or are they the same viruses which just randomly appear?
Okay, so that's interesting. So what happens with the virus is that every time it multiplies, like how Ashwati said, every time it multiplies, it undergoes a small change, so it's just trying to survive in the world, right? Like how Darwin's theory of survival of the fittest. So every time a virus multiplies, it's trying to improve itself by changing a bit of itself. So every now and then you get a different type of virus that is just slightly different from its previous one version, which allows it to survive better. So when this happens is when you get these kind of outbreaks of new diseases and things like that. And this is what we call as a mutation.
Can you tell me a little bit more about virus creation?
Okay. So viruses exist in nature and they are all around us. And like how Ashwati was saying, whenever a virus tries to multiply or replicate in a other cell, so with every multiplication, it tries to slightly change itself to be able to survive better, okay, in the world that it's living in. So every now and then what happens is a change or a mutation, as we refer to it in scientific terms. There is a mutation that happens in a virus that changes it in a way that gives it a survival advantage, so that it can kind of become either more infectious or it can become more harmful to the cell, things like that. So you get these slight different forms of the virus that keep coming out every now and then. So that's how you get different diseases that also keep cropping up every now and then. Was that clear?
Yes, it was.
Okay.
And
Okay.
was there only one virus, or were there many viruses that we just didn't know about, which then came to us and then we discovered it?
Okay, that's interesting because I think viruses have been around for probably as long as the Earth has been around. Um, what we've seen recently is that there were these viruses that were predominantly in the animal kingdom. Like HIV was predominantly only a zoonotic virus or an animal virus. The swine flu virus, the bird flu virus, all of them were just in the animal kingdom. But because the population has grown so much and we are in close contact with a lot of animals, there are every now and then you have these viruses that jump from one species to the other. HIV came, I think, is believed to have come from the chimps, swine flu from pigs, and bird flu from birds. So every now and then a virus can kind of jump from one species to the other and it becomes a new disease in humans. Even I think that's what is also believed to be the case with the COVID-19, although that's still being investigated.
So, when you said that the swine flu, bird flu, and HIV came from animals, what I've heard is that the COVID virus came from bats and snakes and something like that. From because apparently some people in China they eat like these animals, and then the virus passed on to them, and they traveled, and then that's how it spread. Is that true?
Yes, I think that's what is currently believed to be the origin of the COVID-19, the SARS-CoV-2. That's what they believe the origin to be.
Yes, but they're still investigating it.
Yeah.
Why did us humans evolve to get immune against certain viruses? Why weren't we always immune?
Okay, so the way the immune system works is you have two types of immunity in the body. One is called the innate immunity, and the other one is the adaptive immunity. Okay, so the immune system is basically something that protects your body against uh, harmful substances or pathogens, as we call them. The innate immune system is something like your skin, and you may call that the first line of defense, right? So it protects you from outside substances. Then you have certain cells in the body called lymphocytes, and then you have certain substances called antibodies. Now, these protect you against uh, some of the more common infectious agents, but a body cannot, you can't generate antibodies against all sorts of pathogens, right? Very often what happens is that only when a body is exposed to a certain pathogen, like the first time you get the measles or the chicken pox, the body is exposed to it and then it generates antibodies against that particular virus. So whenever you get the chicken pox the next time, you don't get the disease because you already have a protection against it. That is, you have the immunity against it. So it is that the body has to learn. That's called the adaptive immunity. It has to adapt to a new pathogen. So that's in a very simplistic way of how the body's immune system works. So we are not born with immunity to all viruses, We are born with probably immunity to certain diseases, which we don't see in humans at all. But whenever these new diseases come, it is that we have to develop antibodies against them or develop a immunity against them.
Why doesn't every virus attack every species? Why does it only affect some species and not affect others?
I think that probably has to do with the type of proteins that a virus has on its surface, because an infectivity of the virus depends on its protein coat, generally speaking, in very simplistic terms. So there may be certain viruses which have certain proteins on its coat which are able to infect the cells of particular organisms. They're very species specific. So a virus which infects a dog, for example, may not particularly affect a human being because we have certain intrinsic differences in cellular structure in the body. And it works both ways. But as you can see, there are many viruses which can affect animals and human beings at the same time. And these are the ones which are increasing in frequency over the past many years. So it's got to do with the structure of the virus.
So inherently, the cells that you are composed of and the cells that maybe a plant is composed of are different. So a virus is able to recognize a cell and only then enter. So if a plant virus comes in contact with, say, a human cell, it can't recognize that cell, so it can't enter into the cell, and therefore it can't multiply and it can't infect. It's like that.
Then, how did the HIV and the bird flu viruses recognize the human body cells?
That's a very interesting question. So I think again,
It
like what
probably
Ashwati
infects
said,
similar
yes,
cell types.
similar cell types. So it probably had a small ability to infect a human cell, but because for all this time humans were never in close contact with animals, it never had an opportunity to jump from the animal to humans. But as population has been increasing and we are more and more intricately connected with the animal species, these viruses tend to jump from a animal to a human, and then it just gets one chance to infect a human cell, and then that's it. When it's able to enter even a single human cell, it just multiplies from there and it starts a chain reaction.
If there are viruses all around us, what is so special about the coronavirus that is so harmful about it?
Okay, the the coronavirus. So I think the first thing that's most special about the coronavirus is that it is a new virus and we don't know much about it yet. Almost every day there's new evidence coming out as to how the virus functions and things like that. So we don't understand the virus much now. So we really don't know everything about it yet. The other thing is the fact that the coronavirus, one of the first places it attacks is the respiratory tract. There are certain cells in the lungs which line the air sacs called the type 2 pneumocytes. And that is the cell which the coronavirus attacks first. And which is why you must have heard that a lot of people with COVID-19 have difficulty in breathing and they develop pneumonia and they have to get supplementary oxygen and things like that. So it affects a very important cell in the body, number one. The other thing is that not everybody who gets the coronavirus falls sick immediately. And many people don't fall sick at all. They don't even know that they're infected by the virus, but the virus is still infective. The person may still be transmitting the virus in society. So we are not able to isolate people to control the spread of the virus because we don't know whether they're sick or not. So because of this, the virus has been able to spread in the way that it has, because we don't know whether we're actually coming in contact with a sick person or not. I think that is what has made this into a pandemic in the way it has.
If you compare this to previous pandemics like the SARS, which happened, I think, about 8 to 10 years ago, so the SARS virus was something that was extremely fatal. If somebody got the SARS virus, he would die in maybe a few days. So that did not give the virus enough time to multiply and infect somebody else. So the SARS virus is more or less confined to a small geographical area.
And the Ebola is another example.
Everything. All of them, whichever causes a person to become sick very soon and die, doesn't give the virus an opportunity to multiply. But with COVID, a lot of people are actually either mildly sick or they're just healthy. So it's able to just multiply and go from one person to the next and just spread across the whole world.
So for the people who aren't sick with the virus, like the virus is just using it as a rest place, right? It's just stopping there, then jumping to the next person, right?
Exactly. Yes, that's exactly what's happening.
What is a vaccine and how does it work?
Generally speaking, a vaccine is any substance that helps you develop an immune response against a certain infectious agent. Okay, it's something that confers some protection against an infectious agent. There are different types of vaccines, but in a very in its most basic form, a vaccine is a substance which could be either a proteinaceous substance or an attenuated or a kind of a weakened form of an infectious agent, which, when introduced into a person's body, is able to stimulate the body's immune system to develop antibodies. So, if I take for example, a polio vaccine. Polio vaccine is something that's called a live attenuated vaccine. So this is actually the polio virus, which has been made very weak and almost inactive. Okay. So when you introduce that foreign substance into a human body, the body's immune system identifies that this is foreign and it starts producing antibodies. So you're basically stimulating the body to produce antibodies to protect itself against a virus by not actually causing a infection. So this is generally how vaccines are designed, and this is the basic principle of how a vaccine confers immunity to a person.
Yeah. And the antibodies last in the body for a long period of time. So the next time you encounter that virus or the bacteria for which you've been vaccinated against, your body's prepared to fight it.
Yes.
So you're tricking the body into thinking it has been infected.
Yes.
So it's basically like a practice, but not exactly a practice, right?
Exactly. I think you couldn't have put it better.
Is it possible to eliminate a virus?
So it is theoretically possible, and it has been done. Like in the most recent past, you would know in the last couple of years that polio was eradicated from India. Polio is also a viral disease. The way it was eradicated was first we understood how the polio disease works, how we understood how the polio virus is causing the disease. And then there was a vaccine that was available, which was very effective. And then there was a nationwide, a large scale immunization program that went on for, I think, many years, decades together. And it was this kind of a sustained, planned effort which led to the eradication of polio. Now, this may not be the case with all viruses, but it is definitely possible. It's only limited by our understanding of the virus and its mechanism.
So, from what I've heard, like all around, and from what you just said, I think vaccine is the only way we can stop the COVID virus. So, I encourage all my listeners to get vaccinated right now.
Absolutely, Vedant. You're very right. That is the only way to get out of this pandemic. All of us have to get vaccinated.
And take precautions.
Yes, and take precautions. Even after getting vaccinated.
Yes.
What are those precautions?
So the precautions would be, so because we all know that the COVID virus spreads mainly via the respiratory route. When anybody coughs or sneezes, and if somebody is in close contact to that person, you can inhale the viral particles which are released into the atmosphere and you can get infected yourself. So because of that, the most important thing is to wear a mask and at all times. And the other way that, again, the COVID virus spreads is through fomites. That is, you could have viral particles lying around in the surroundings and people are not yet sure as to how long it can remain infective once it's outside the body. So practicing hand washing is important because if you touch something which is possibly contaminated with the virus and you take it it up to your nose. It can easily enter your respiratory tract through your nose, and again, you can get sick. So practicing hand washing, always avoiding touching your face area when you're outside, and wearing a mask, coughing into your elbows like that, practicing proper cough etiquette. These are the main ways by which we can, and isolating yourself. Another important thing, if you think you have a fever and a cough, even if you just think it could be the common cold, it's best to isolate yourself and to avoid coming in contact with people.
And people who are at risk are generally the young children and the very old, very elderly.
Yes.
So it's important to take care of them as well.
If the young children and elderly are at so much risk for the virus, why isn't the vaccine available to the young children?
Okay, this is a difficult question to answer. So generally, you need to understand that a vaccine is a foreign substance, right? And the vaccine is stimulating a person's immune system to generate antibodies. Okay, so it's also important to remember that the body's immune system is also maturing as the person grows in age. So generally, we say that a person's immune system is mature enough to handle these kind of insults, probably by the time that they're between 12 to 18 years of age, maybe. Okay, so in a child, if we try to introduce a vaccine that we've not tested properly, the child's immune system may not be strong enough to actually generate antibodies. And we don't know it. So that's why the trials are going around, I think, across the world. They have found in some vaccines that you can give it up to 12, children who are 12 years or older. They're trying to see whether the vaccine is safe for children above 2 years of age. But that has to be done properly, and they need to be sure that the children are not going to be affected by the vaccine, and only then they can start. I'm sure the vaccine will become safe for children soon. It's only a matter of time.
I take my annual flu vaccine, so I think I will be okay to take the COVID vaccine. But I am a little bit scared.
We'll have to wait for the scientists who are working on the vaccine to tell us that, they have tested it and then they are sure that nothing will happen. It's only a matter of time.
Okay, sure. Now I'm not scared anymore, I think.
Okay.
Vikas, I've already asked you these questions earlier. So, Aswathy, what made you choose to be a doctor?
Okay, Vedant. So growing up, so both my parents are doctors, and some of my aunts are also doctors. So I was always surrounded with conversations about medicine and patients and how they were treating their patients. So I grew up getting interested in it. And so that's why that it was a very natural choice for me to choose medicine as a career when I grew up.
What are your hobbies?
Okay, so my most favorite hobby is to read. I love reading books. I also love listening to music, and I like cooking.
Oh, nice. What are your favorite books?
All right. So my all-time favorite book will have to be the Lord of the Rings trilogy by J.R.R. Tolkien. He is one of my favorite authors. My other favorite author is P.G. Wodehouse. I love P.G. Wodehouse books. And recently, I've also been reading a lot of nonfiction because I'm interested in history. So yes, these are my favorite books.
Nice. Even I'm interested in history. My parents have bought me lots of history books.
Oh, wonderful.
I find it very fascinating.
Yes.
Thank you so much, Aswathy and Vikas, for coming on my show.
Thank you, Vedant, for having us. We had a wonderful time.
Yes, this was very fun.
We had a lot of fun.
Yep, this was super fun. I learned a lot.
Okay.
Dear listeners, follow my Facebook page, Curious Vedant, to get updates on my upcoming episodes. To listen at leisure on your phone and get notified about future episodes, Subscribe by searching for Curious Vedant wherever you get your podcasts, such as Apple Podcasts, Spotify, Stitcher, Google Podcasts, and many more. You can also listen to my show on CuriousVedant.com. Thank you for listening to Curious Vedant, and don't forget to rate and leave comments